So it's another set which we've done several times before. It's an Amstrad 900. And, you know, it doesn't matter how many times we show these, people are still interested because all the repairs are different. This isn't a service, it just isn't just tune-up, it's a repair. So it comes with the original Action Man mic, which is a bit like hen's teeth. And does it come with the original power lead? It comes with the original power lead as well, which is double hen's teeth. And when you are offered an Amstrad 900, it's always the genuine one, because this is the one which doesn't have the Roger bleep, doesn't have those extra switches there, which is the 901. So all these work really well. So there are no fake Amstrad 900s, so it actually makes them a better set. I'll have to look at the chap's email. This is an end user, which we don't normally do, but we are doing with the lockdown situation a bit, because I know the shops are shut. Why can't I get this off? This is where we wreck the speaker. Wow, that took some doing. Not sure I like to see two resistors there. We'll see what the power output is, because that could well limit the power. Gone from one extreme to the other. The silly people who remove the ballast resistor and cause the PA to fail. To the opposite. I think it was something about dodgy receiver or something. So we'll get it connected to the test equipment. So, switch on. RF gain up. Squelch down. Well, yeah, the volume control wants... Hopefully we can clean that. Get the service saw on it. I don't want to switch it on and off repeatedly with the power on, so we'll just waggle it around with the power supply off. See whether that's brought a bit of an improvement. Yeah. So, let's look at transmit. I'll switch picture in picture on, and then we can look at that together. Oh dear. 2.7 watts. I think we'll start by replacing that ballast resistor rather than try and get more out of it any other way. So, see whether we can hear anything on receive. That's 0.3 of a microvolt, and so let's look at that on the SINAD meter. Incredible 0.29 of a 0.29 microvolts for 12 decibel SINAD. So apart from the fact the detector could well be out because it sounds a bit ropey. So first of all, just check it's on frequency. That was the signal generator you were looking at then. So we'll key it up. So it's dropped. It's as they do. It's still in spec, but it's dropped. So let's see whether we can adjust that. Some of these are now they're 38 years old, are beyond the adjustment available to us. I'll tell you what, this is coming up. And there's still some more left, so it's going to carry on for a few more years yet. And by a few more years, I mean another 20 plus. So just we're warming this up. We'll just get that up a bit higher. Okay. Let's just have a quick look at the deviation. Wallow, it's as quiet as a mouse, that. Oh, I'm going to have to clean the microphone contact. We don't repair microphones, so, you know, if there's something wrong with the microphone, buy another microphone. By all means, keep this, because it's original, but the cost of replacing leads and the labour involved in doing that is beyond the cost of a new mic. Wallow, you know, we're not hobbyists at the end of the day. That looks low. So the next thing, I'll probably do the deviation with a new mic so we can see where we are with this mic. But all we're going to do is clean the contacts in there. So what does that leave us to? Oh yeah, I wanted to just look at the deviation. No, we've looked at deviation. Just wanted to look at recovered audio. And it's really lousy. So if I recall, that's the detector coil. And it was out. Something's making this go off. Of course, can I make it do it again? Of course I can't make it do it again. Right, well I'll take a break and we'll come back to... Okay, so I've got the mic apart. There were some bits of paper to stuff it. And, you know, these were discontinued quite early on because they were problematic. So as I've said earlier, by all means have a original mic, but you might be better off, if you want to use the set rather than just display it, to actually get a modern standard replacement mic. So I've cleaned the switch contacts. Now one of these screws didn't seem to be tight, so that's going to be interesting when we come to put it back in. And cleaning the contacts has made a big difference. I'm not going to try and tighten these forever and ever. One, two. 1 2 1 2 1 2 wallow 1 2 1 2 1 2 wallow. It's a bit low, isn't it? 1 2 1 2 1 2 1 2 wallow. I think we'll deal with the deviation right away, actually. Very low. See where that is. 1 2. That's now too high. One to wallow. There we go. Let's listen on the monitor receiver. Testing 1 2, testing 1 2, 1 2 1 2. Hello, testing 1 2 3 4 5 5 4 3 2 1. We've got rid of the rustliness. Yeah. So I got rid of the packing piece and just cleaned the contacts. Probably what the issue was and why the packing piece had been put in there. But if the customer wants to put a packing piece back, well, I'll let him, but it's leaving here working. Right, so that's covered that. We're going to start from scratch. I've found the service manual in one of the bathrooms here. I wonder why that was. Mr. Chippy comes back today, later on, so we'll have... he's been away for 2 weeks and 1 day. Right, we'll get the multimeter out because the VCO really does need attention every time on any radio that uses this chassis. So I have to get the manual out every time because I have a memory like a sieve. Or do other countries have calendars? I don't know. So I can't even remember whether it's a floating chassis or whether it's a negative earth chassis, so we'll put the negative onto the crocodile clip lead and do it that way. So we need to locate capacitor 9. It's the far side of capacitor 9, which I'm sure is that one there. So the crystal, yeah. Capacitor 9, the far side, so with the radio facing me, that's there. And we start off with the radio on channel 40. So, set to transmit for 4.5 volts. Well, look at that. Spot on. I'd go to the foot of our stairs. Well, I would if I had one. I live in a single-storey building in the Britain called a bungalow. So if that needed adjusting, then which one is it? I'm missing a stage out. It's T1 for receive. So start again, forget all that. Transformer 1, and we want 2 volts. So we're just going to pop that down a fraction. I think that's near enough. And then we're going to transmit. And we look for 2 volts. And once again, we need to adjust it this time with the trimmer capacitor. You know what? These are interactive. So when I let go of transmit, it's still 2 volts, so that's fine. Then we go stampeding towards channel 40. And they expect that to be in the 4-volt region. The point is, it's in lock, so that's done. Because you can end up with a minus voltage there, and then you start with channels dropping out. I think we need to deal with that next, so I'll switch the soldering iron on, and before we start looking at the transmitter, we'll get rid of that. Right, well, there is something I've just spotted while I've just been looking for dry joints, and just in case, because when I was doing that receive, something was going off for some reason. Anyway, that aside, you know what I discovered? Oh, it's gone, hasn't it now? That would have gone, wouldn't it? But there was a bit of solder floating around near the audio IC. I'll just spot something else while I'm at it. Just unsolder that. Right, I'll switch on. Now, so having changed the resistor and made sure we're on channel 20. Oh, look at that, it's 4 watts. Well, isn't that interesting? I wonder what it is on channel 40. 4 watts. What is it on channel 1? 4 watts. So take out the 2 bodge resistors, put in the correct resistor, and Bob's your uncle. That saying goes on to Fanny's your aunt. And I actually had a great aunt, Fanny, who lived in the United States. And she would be in her, I think she was in her late 80s when I was a little boy. And she lived in, I think it was California, and it was Sunset Rest Home. Didn't sound like you were coming out of there, did it? Well, she didn't. So that was Aunt Fanny. You just wouldn't call anybody that name, surely, these days. Right, move on. So we've done the transmit, we've done the deviation. We just need to check that the TX meter is reading something like. And to do that, we need to actually put the radio into its low power mode, which should be 0.4 of a watt. But it's not adjustable, and it rarely is exact. On this occasion, it's 0.25, 250 milliwatts. And what's supposed to happen is that's supposed to be one light. So we need to adjust the TX power meter, which is there, for one light and transmit, and also on channel 20. Then go to high power and make sure that at least 4 are lit. Well, 5 are lit. Well done. Another adjustment done. That brings us on to receive. So once again, I'm going to check that that detector is right. Because I have looked for dry joints. Turn the bench light off. one, isn't it? There we go. Now we'll go onto the SINAD meter. Spot on. Fraction improvement there. That was spot on. Now these IF ones. There's a higher signal on for these. Nearly. Now we'll look at the SINAD reading. So 12 dB. Yeah, 0.25 of a microvolt. I think, was it 0.27? But I think just adjusting the detector has brought that in a bit. Certainly not got it going off now. Now we'll look at the squelch. This is where you're let down by this chassis in general. So let's set the squelch to full. I like a radio to be able to squelch out S9. Just see if we can knock that off a fraction. Probably a slight improvement there. Let's see where the sensitivity is at the other end. So set the squelch to threshold. I'll show you the attenuator controls. Turn the squelch down on the radio. Now it doesn't hiss at all, and that's because we've got the squelch too high. And this is where this is the whole letdown of this. It doesn't open at all, so we actually need to back that off. Squelch set to minimum, straighten at 0.3. and right down to 0.06 of a microvolt. Switch the signal off and it goes. So very, very sensitive. But now at the full end, what's the maximum we can achieve? Let's have a look. So turn the squelch to full. Those 100 microvolts. Let's make sure it will hiss in the off position. Yes, it will. But sometimes these sets won't. I've just unplugged the aerial lead from the test equipment, and it is hissing at minimum squelch. But not all these do. It depends how that preset's set. So squelch is down, the radio is hissing. But I tell you what, it's not hissing all the time. So I don't want to back that off. But rest assured, the slightest whiff of a signal, and it will come in. Let's back this off a fraction more. And see where our maximum squelch now is. It's 30 microvolts. I think that's the best compromise. That is the letdown, as I say. Turn the signal generator off. turn the squelch down, unplug the aerial, still works. So I think that's it, job done. So we'll put it back together.